Okay, I'm back again. I think we've got audio and we may have video as well. I'm sure you let me know if either of these isn't working. So we've had a quick look at the stack example. Again, proceeding from a very simple test to something a little bit more sophisticated, ending up with a useful groundwork done to verify that a component works successfully. And then we're able to replace that component at the very end with a different implementation, relying on the tests, the body of tests we established to allow us to verify that that switch of components was viable. We took out the stack implementation based on arrays and replaced it with a stack based on a collection. Let's take another example now. This one is also from the same source. It takes us on a slightly different tour now, this time of a perhaps slightly more involved case study. Let's see if we can make some sort of sense of it. The idea is we've got a video player we want to build and possibly a control system around the video player. And again, we're choosing to specify our system under test using an interface. So we've got fast forward, rewind, current position, mark position, and go to mark. So these are all features of the video player controller we want to implement. The idea is that the player allows us to move in seconds forward and back in a given tape. And then we're allowed to mark individual positions on the tape with a name and then go to those positions subsequently. It's not essential we understand all the details of this for a moment. We're certainly not going to talk about how we would interface with a device. We're just really looking at what might be involved in building a class to support a simple operation like this. So what will we do? Well, here's our system under test in this example. We note we're implementing the video player interface here. And the video player then supports methods we've just outlined. In this example, you'll notice our first attempt is to implement all the methods, but unlike the previous example, we don't do anything yet. They're all stubbed out or all empty. And this is quite typical of test-driven development techniques. You're building a system. You have an idea about the features you want. Maybe you've evolved a set of method signatures. Maybe it's an interface that you're going to implement. But as yet, you don't know how to do it. You have some initial concept, and here we're going to use a map to hold the bookmarks, if we call them that, in the video player tape. And we're going to initialize that map, and we're going to also set the overall duration of the recording. But we're not really doing anything else. We haven't thought about how to go to mark position, rewind, or fast forward yet. One of the principles of test-driven development, and again we'll be revisiting these several times in the next few weeks, is that you do the simplest thing that'll work, and you make the smallest changes to go from one state to the next. Hopefully those states are from green or running test to green or running test, augmenting or improving the test as we go. How might that work? Well, again, we might start with some specifications for our test. And these maybe are jotted down, or maybe they're kept in a to-do list, or maybe they're in our head initially, or maybe we're only doing one or two of these in advance. I mean, specifying them one or two in advance of actually implementing the code. So verifying the initial position is 0. Seems like a trivial test, but it would be an important and simple thing to verify. Verify that if we go forward by some amount and then rewind, we should be at the initial location. So we're checking the basic veracity of our cursor, if you like, into the recording itself. Do this in reverse. Seems to be logical. And then we're checking out what happens if we go beyond the end of the tape. Particularly if we go beyond the end of the tape and then we rewind, what should we do? Should we take into account how far we've gone beyond the end, or should we discount that and just come back the delta? Again, these are part of the considerations we'd make as we design the system. Maybe these tests are composed having inspected what we were specified by the customer or by the engineers building the actual test drive itself or the software player. Start again with our fixture video player test, and in here we create a single video player object we're going to use, and then we initialize that fixture in the setup and destroy it in the teardown. Again, as I mentioned in the previous, when we look at the stacks, each test must be isolated from the other test. So setup is run before each test, teardown run after, and we're getting rid of all evidence. So the tests can't interfere with each other, or one test can't influence the behavior of another test. We don't want any temporal relationship between the tests themselves. That's quite important. Here is our first test. Very simple. Verify that you're at 0 initially. Test beginning of tape is what we're calling it. And this is a system under test. We do nothing really to support this test. We just return the current position, which has been initialized to 0, hopefully. And again, we're relying here on the default initialization of int fields in Java for that to happen. Maybe that might give us pause for thought, and we would explicitly set it to 0 just to be sure. Second test, we're doing a test fast forward. We go fast forward 30, we rewind 30, and then we verify that we're at 0 because we were at 0 initially. We could have implemented this test without the system under test being updated. So we could have done it before we did any work here on this rewind and fast forward. And of course, if we did that, the test would have failed. It would have been red. We make these changes and the test goes back to green. So Siobhan discussed this red-green cycle with you last week, and this is an example of where we might have done it. Third test, rewind. It's the mirror image of the previous one. This time we want to implement rewind, and it more or less mimics fast forward, and we'd be expecting this test to pass now as well. So we've moved our implementation along a little bit. Here's then a test we should consider. What happens if we move beyond the end of the tape and then we do a rewind by the same amount we wound forward? What would happen? We've encapsulated this expectation in this test here. So go forward 60, having started, however, at 50, which means we've gone beyond the end of the tape now. Rewind 60, and we should be back to 40 in this instance. Now, our initial implementation is going to fail when we try this. That is, this version here will not produce the effect we're expecting. We'll end up being out of place in the test, having assumed the beyond the end of the recording was in fact part of the recording, and we would have recorded backwards to get out of step. Here we've rewritten the fast forward test, and in this rewriting the test now passes. So we check to see, and we only go beyond the end of the test at the end of the tape itself by checking against the guard position. So if we can't go beyond the end, we actually do our update. Otherwise, we set the current position to be the very end of the tape. So it's just a little bit of logic. Don't worry if it's not quite making too much sense. The key point here really is that we're evolving the test and the system under test concurrently. We're deliberately provoking an error, fixing the error, and thus stabilizing our system in sequence. Same thing happens in the other direction. We want to rewind beyond the start of the tape. Our initial shot at this will cause a failure in the test, and then we replace that initial version with a revised version, which should yield a test pass for us. 6 and 7 then are looking at how we would mark positions in the recording. So in this example, we're fast forwarding to a given location. We are marking the location. We're fast forwarding again to another location and marking that. So this is, if you like, setting up the test conditions. And then we're exercising the features we consider to be important for this test. And that is going to a mark and verifying we're there, and going to another mark and verifying we're also at the correct location, in each case 30 and 60 in this instance. This is quite typical test structure. Performing some initialization that happens in the setup. Exercising the features. This is happening in the fast forward, mark, fast forward and mark. And then verifying the behavior. That's happening in the asserts as well as the goto. And then finally the teardown, which is happening in the teardown method, which is destroying the test after the test is completed. In fact, that pattern is so common, it's often called a 4-phase test. And it's one of many styles of test you'll come across, but the 4-phase test is one of the more common ones, and we'll be seeing more examples of this. So this test example then we've worked through has again demonstrated a key feature of test-driven development, which is the co-evolution of the system under test and the unit tests themselves. In fact, we could even build the tests before we build the system under test. The test will fail initially. Initially, the test won't compile because the system under test doesn't exist. As we augment each test and implement each feature, we're gradually moving the application forward. Sometimes it's been compared to growing or gardening a solution as opposed to designing or building one, in that we're proceeding in modest increments all the time, relying on the unit test infrastructure to give us back red-green indications of how we're doing. Just a few notes on our course web before I move on to the next section. You're hopefully getting used to using it by now. We're putting up the recordings weekly. These recordings generally appear inside the tab where the talk took place. Occasionally we're spanning talks with tabs. So for instance, this video here extends across these two talks. So we've just kept them in one video if it made sense to us. Hopefully you're also getting to find your way around the labs here. All labs are available on this tab. And then you're getting used now, I think, to navigating the labs themselves in the sequence of steps. From within a lab, you can go back up to its parent easily enough. And also when you're in a lab, you can switch to any other lab by clicking on the tree icon here on the left. So you can zoom around within the labs if you want to just consult previous labs or subsequent labs. In general, we're posting the solutions to the labs at the end. These are links out to a GitHub repository where you can download the project at that particular lab. If you move up a little bit, of course, you'll see we can access the entire most recent version of the lab here, and you can wander in and inspect any of the code if you're a little bit if you're just a little bit curious as to how the lab is going or how your particular implementation might be looking. Okay, that's good. I'm happy enough now with our progress so far. We're taking a short break, and when we come back, we're going to be looking in detail at what you did last week. Hopefully, it'll make a little bit more sense now that we've had some more exploration of basic test infrastructure as we've covered so far. Okay, so I'll see you in a few minutes, and if you want to ask any questions now, I'll be standing by.